In the last video, we got all of the core mechanics for our breakout game functional. We got our paddles moving, we got the ball bouncing around, ball shooting off in a random direction, bricks getting destroyed by the ball, and the ball getting destroyed when it goes off the edge of the screen. We primarily did this by taking advantage of the physics system to do most of the heavy lifting on that logic for us. But now we got to do some real heavy lifting of our own and add a game manager, something that can control the, manage the game. Oh, wow, what a tautological definition. Something that can keep track of the score, something that can keep track of when a ball goes off the edge of the screen, can spawn in a new ball, and can fire it off again. And then when you run out of a certain amount, it will know not to keep doing that and to switch to a game over state. So we're going to do that with a game manager. And I'm just going to call mine game manager because that's a pretty good name. Now for fun legacy reasons, when you make a script called game manager, it gives it a new icon, a little gear icon, but it's still just a script. It's still just a game manager.cs script. And then I'm going to make a new empty game object in my scene. We'll also call it game manager. Put that at 0, 0, 0. And we'll put our script on that object. And I like to move my game manager to the top of my hierarchy too. Just like I know where to find it. Okay, so to spawn the ball in, to spawn new balls in, we're going to need to turn the ball into a prefab. So let's create a new folder. Called prefabs. Now we could take the existing ball, we could reset its position, and then add another force to it instead of destroying and creating a new one. And we're not going to do that because what about multi-ball? Come on, that's like the first upgrade to do. So let's take the ball and let's make that a prefab in our prefabs folder that we, of course, are always going to make to stay nice and organized. Of course. So this is going to need a function to spawn in a new ball. So let's write a nice optimistically named function called spawn in new ball. And this will instantiate the ball at its appropriate position. So we need a reference to the ball's prefab. That's of type game object, not of type prefab. And just to be clear, I always make a suffix of prefab whenever I have a game object variable that is of type prefab. And that's going to be public, so I can set that up in the inspector. And now I need to know where to spawn the ball in. Currently it's at 0.6, negative 2.24. So we can type that in with code. Let's not. Instead, let's make a new empty game object and call it ball spawn position. And that's all this object is going to be, is it's just going to represent the position in space for the ball to spawn in. And for this, this little icon up here on the top left of the inspector, give that a little circle or a diamond or something. That way I can click on it. Even though it's empty, I can select it, and I know where to, I can visually, I'm like, that's where the balls will spawn. So in our game manager, we'll make a public transform, which will store a reference to the transform, because the transform is the component that tracks the position of an object. So my game manager, I can give it the spawn position, and I'm going to show you something else. If I take this ball and I drag it into here, I haven't actually assigned the prefab to this object. Watch what happens when I delete this ball out of the scene. We go missing. So another way to make that mistake is if I use the this little bullseye thing, I might see this little ball prefab pop up, or I might click on assets and see the exact same thing. And this is the one I want. In my scene, this is the one I don't want. So to prevent me from making this mistake of referencing the instance of the prefab instead of the actual prefab in my hierarchy, I'm going to just delete the ball out of my scene. And now I just can't mess up. And I could, or just drag it from the prefabs just to be sure. So, well, now we don't have a ball in our scene. So on start, we'll need to spawn in a new one. So now, how do we instantiate an object? Well, we instantiate it with the instantiate function, which clones the game object, clones an object that we give it. We'll give it the prefab, we'll give it the location dot position, because that's a transform, and we'll give it a quaternion.identity. And this we covered previously, but just a quick recapitulation. Just a quick recap. The instantiate function has a few different versions of it. And the one that we are going to be using, and it clones an object, the one that we are going to be using is we give it first the object we're cloning, then a position, and then a rotation. So if we give it these 3 different data types in this order, then it will work. So here's the object we're cloning. Here is the vector 3, which is the dot position property of our empty game object transform. And the identity rotation, which is just a shortcut to have a non-rotated. It's just a rotation is 0 degrees around each axis rotation. Identity being so our ball spawn position is there. Our game manager has a reference to that. It's here. We've got the ball. It's the prefab, and there is no ball in the scene. But on start, one should get instantiated and fire off in a random direction. I feel like I want a little bit of a delay, but we'll deal with that later. The ball shoots itself off in a direction in its own start function. We don't need to deal with any of that logic. That's great. I love that. I want this game manager to be as simple as can be. Next is the sort of the big tricky part, which is how do we get the ball to report back to the manager that it has died, that it has gone off the edge of the screen. So for starters, we'll just write a function that's like ball gone off screen. What is the name for that? Ball death, ball player failure? I don't know. I challenge you to name that function better than I have. And then because that's a terrible name, let's give a little comment here that is called by the ball when it goes off. Great. And for us, we are going to spawn in the new ball. So now the challenge is to get this function called by the ball. So we need to take the game manager, but I don't have a game manager variable. I don't have I can't reference it. I can reference the class, but I can't reference it. I don't have a reference to it. So let's store a variable in the ball. I'm in the ball script of type game manager. I'm just going to call that game manager. Sure. I just separate public and private. Not important. But we need this to be equal to something. We could find it is equal to game object.find. We could type in the name of the object. This is a terrible thing to do. We should never do it. It's very slow. And then we can't rename our object, which is bad. We could do find object of type, which will also sort of do get component calls and search through the hierarchy for an object until it finds the first one of this type. And this would work. Our game would work again. But that's not what we want. Instead, we're going to use a new pattern where the ball doesn't have to search for the game manager at all, because any approach to searching is going to be sort of slow and prone to bugs. If I have multiple game managers in my scene, I don't know which one I'm going to end up talking to. Now, we know that we shouldn't, so maybe that's making us think singleton pattern, but that's not necessarily something I care about yet. Instead, we're going to do something close to dependency injection, which is a fun keyword, but it's the version we're doing is so simple that we don't need to talk about dependency injection. We're going to have the game manager just tell the ball that it created, because it created it. It's just going to tell the ball, hey, I'm your manager. I got you. You talk to me. I created you. You talk to me. And now if we do have multiple game managers in the scene, they both create balls. They get talked to. It's great. It's fine. And we might want to have this ability to control who's creating what ball or something like that. Maybe with multi-ball, we want only some of the balls should spawn in new ones when they die. I don't know. So to do that, we need to get a reference to the ball in this spawn new ball function. So what this instantiate function returns is going to be a game object. It returns, as we real quickly saw, it returns a copy of the thing. It returns a reference to the thing that we copied. So how do we get the ball component on a ball game object? With the get component call. Easy. And now I just need to set the game manager property of the ball. Unfortunately, that property is private. Instead, we're going to write a function on the ball object, which is going to be public void set game manager. So we'll have it tell us who our game manager is. So we'll set our manager variable equal to whatever we get told. And we're going to do that in a setter function so that we could add debug statements and we could investigate this code and we could add other logic here if need be, instead of just directly editing a public variable, which is a little bit trickier to debug and to investigate. So I think it's a good habit to use these when we're doing injection sorry, I can't type and talk at the same time. When we're doing injection, I think it's a good habit to go through a function that we write, because it makes it so much easier to debug when things go wrong. This is a very simple example, so we're like, oh, what would go wrong? Things go wrong. This is a reference to whatever the instance of this class is. It's not the game object, it's specifically the game manager. We can use that in any class. It'll be the keyword this. You can't name a variable this. This is reserved by the word this, which always refers to whatever the surrounding object is in the scope that we're working in. So now the ball gets its manager set, and we know that this won't be null, so we can call a function that is private by default. So in order for the ball, a code somewhere else, to have access to this function over here, we need to make sure that it is public. Public void ball gone off screen. And now we have access to it. So let's see if that works. So we don't need a singleton. We don't need any static properties. We don't need to do any searching. The game has a game manager that will work sort of without any of that. And we could have multiple game managers and more complicated setups, and it will be nice and it'll work. And we got Brick Breaker. Look, we got Brick Breaker. Amazing. So our next step is either to have the ball sort of pause for a moment before firing. And I like that. I think that's important and worth doing, even though that's just a small bit of juice. So I guess we'll save that to the end. Instead, we'll start with having the game manager keep track of how many balls have gone off the edge of the screen. And here is an interesting question, which is, how do we store our data for the game setup? If we have a certain number of lives, and every time the ball goes off the edge of the screen, we could lose a life, that makes sense. We just make an integer, call it lives, ball gone off screen, decrease the number of lives. But it also makes sense to store the data in a more direct and representative way. Instead, keep a count of the number of balls that have gone off the edge of the screen, and then compare that to a number of lives we have. So that would be deaths, and then like increment that instead of decrement lives. And the answer is like, which one should we do? I tend to write my code, I sort of tend to have it both ways. I tend to sort of store my logic in very representative ways with very clearly named variables that make sense and do what they're told. But then I also have the things that matter that I want to display in the UI that tells me how many lives I have left. I need a number that represents exactly that value. That is going to be some, total plus, total minus deaths would be equal to whatever that is equal to. So I like to do it both ways. In this case, this game is so simple that I really can't justify saving it in that more representative, that more like, let me just measure all the things that are happening and then do logic to get to my gameplay side. I think just having an integer that is that gameplay side of things is the way to go. So in start, we'll set lives to be 0. Lives, that word's going to be gibberish to me. And then whenever a ball goes off the screen, lives minus minus or equals lives minus 1. Or minus equals 1. Your call. Three different ways to write the same code. The only wrong answer is to leave all of them in. And now that answers another question you might have had, which is why didn't we have the ball call the spawn in new ball function? Why didn't we have the ball just call this function? Why did we go through this function before? And that's so that we can wrap up some logic like checking if we have any lives left. We don't want it to be 0 on start, do we? That was wrong. Say 3. So we start with 3, we go off the edge, that's 2. We go off the edge, that's 1. We go off the edge, 0. 0 lives remaining. It's going to take a second to test this one, isn't it? We'll fast forward. Great, it worked. So the next step is to manage our game state. We've made a lose condition. We've made it so that no more of these things go off the edge of the screen. We don't have the win condition yet, which is if there are no more bricks left on the screen. We'll get to that later. But we'll start with the game state. Because I want to ask the game, like, what is the current? Have we won? Have we lost? Are we still playing? What's going on? And the answer to that would, we'd have to do some logic. We'd have to like check if this variable is greater than 0. But I really want a variable. I really want a little object of data that I could just look at and be like, okay, win, lose, playing, loading, like what's the current game state? So I'm going to introduce a pattern that is, again, maybe a little bit more complicated than we need for a game that is this simple. But is the whole point of this is to have a simple game to explain these patterns in. So just, it's come with me on a journey. I want to introduce a game state variable. So some variable that's value changes, and when it's equal to different things, then it is, I know what it is. And we could make that an integer. Maybe if it's equal to 1, then we're gameplay. If we're equal to 2, then we have won. And if it's equal to 3, then we've lost, right? Or we could do a string and we could just like give it a name equals to quote gameplay unquote. Those are both terrible solutions because they're hard to read, hard to debug, and tricky. Instead, we're going to make a new variable type that's just going to be the game state. We'll go to our scripts and we're going to make a new script and we'll call it game state. But we actually don't want any of this. We don't want any of it because we're not going to make a class. Instead, let's just delete that. Instead, we're going to make a enum, which stands for an enumeration, which is a sort of, as it gets compiled, it becomes integers. But as we work with it, we're going to have nice labeled, easy to use properties. And we're going to call it game state. So instead of class, instead of a public class game manager, we're going to have a public enum game state. And our options are going to be, let's say gameplay, comma, game over, comma, victory. We can add more later if we want. So we have an enumeration. It's going to be a data type that is basically a drop-down list. It can be one of these options. You may have used enums before. Let's make it public. You may have used enums before. Key code is an enum. There's a mouse in my walls. Key code is an enum. So all of these properties just refer to some number that the system understands as some important thing. And then force mode and that add force function, these sort of 4 different options we can choose from. Those are both enums in C#. So we have our own, I've gave it its own file. I like to do that. We could have put this in the other file, but I have lots of files and they're all very small and I think that's fine. Game manager, game state. So now I can make a variable. Let's make it public just to show you something really fun about this. public game state, game state. And what's fun about this is if we make that enum, this data type that can, a Boolean can be true or false. Well, this data type could be game over, gameplay, or victory, and it can't be anything else. When we serialize it in Unity, when we make it public, we get a little drop-down list. How cool is that? I love that. I love using enums for like settings and configuration things because it's just, come on. Having drop-downs instead of having to remember if this is 1 or 2 or 3. You just, it's the right tool for the job. So anyway, in start, we'll set our gameplay or game state equal to gameplay. It would be like when we make a new one, its default value would be the first one. But if we go in and we add something later, like loading or intro animation or something, that wouldn't work. So I'm gonna just set that myself. Here we probably want to make a public integer for max lives or total lives. Sorry, I got distracted by adding where I was thinking about how to set up my game in the inspector, and I was like, yes, I want to determine that number. Total number of lives I have. Okay. But I have a game state, and we'll force it into gameplay. And if our lives will decrease, if lives is greater than 0, we'll set our game state equal to be game over. Cool. So now I can see here, because I made it public, I'll change it back to private, which is what it should be, because we shouldn't be able to edit it. Change it back to private, but we'll test it. And I can see here, my dropdown has changed to game over. Cool. I die once, my lives becomes 2, it becomes 1. Maybe it's this. I need to do that after. Do I have the numbers right? Am I off by 1? I might be off by 1. Deal with it later. Easy fix. Great. So now let's figure out how many bricks are left in the scene. This is a tricky question. If every time a brick dies, we tell the game manager, and then we can either count up the number of bricks left in the scene just by searching, or we can already know how many bricks are in the scene, and then every time one goes away, we could decrease that value. And then as long as we don't add any bricks while the game is running, that will work. If we just like know how many bricks are in the scene and I set that value and then I decrease it, it should match. That's dangerous. I don't like that. I don't like that should match logic because that feels to me like prone to bugs. So I think I actually want to do it the less efficient way in code, at least in my prototyping stage, of just actually searching every time. So again, I want my game manager to be sort of injected and referenced by these bricks. So here I'm going to make it public. And just like the ball, we're going to have a function called on the game manager by these objects. And that's going to be game manager dot something. We have to write that function. So ball got off screen, brick destroyed. Called by the brick when is so we'll call it by the brick when it's destroyed, and then we will check how many bricks remain, and if there is 0, actually if there's 1, because the one that's being destroyed hasn't been destroyed till the end of the frame. If there are no more bricks left, then we will know that we have 1. So let's just see that it adds that. In my brick, I need to give a reference to my game manager. There we go. Just right here, drag into that slot. And it looks like the ball just went straight into it, and it did get destroyed. Great. So now I need to check how many bricks are in the scene. How many objects of type brick exist? So we're going to use that game object. The one that I wanted to avoid earlier find object of type or find objects of type. We could use tags too, but we'll start with type. Because if we have different types of bricks that work differently, we might want to measure them differently. But we'll just do it the easy way. And we'll make this a variable. This returns an array of whatever type we're searching for. So let's bricks, and we'll set that equal to that. And then, but all I really want is to know how many bricks are in the scene. So let's debug.log that. Bricks in scene plus bricks dot length. The length of the array, and where the array is every single one that still exists. And I suppose I should make a few more bricks. Great. Sort of surrounding the spawn location. 6, now we have 5, but there's 4 left. Now we have 4, but there's actually 3 left. 2, but there's 3 left. And then, or 2, but there's 1 left. And then on this one, it will say bricks in scene 1. So what I actually want is to know when there's only 1 brick left, which is to say when the last brick has been destroyed. When we could only find 1 brick that is the last dying brick. If bricks dot length is less than or equal to 1, game state equals game state dot victory. Whoops, what did I do? Game state equals game state dot victory. So we'll just check if I only have 1 or fewer. I don't know, maybe 2 got destroyed like instantaneously or something. Maybe you have animations that are hiding that destruction of them. So game state equals game state dot victory. Nice. But then the ball will keep spawning in when the game is over, which is no good. So we want to check. We want to only spawn the ball in if the game state is gameplay. If we're in game over or if we're in victory, we don't want to spawn in the ball. So when we get that function called, we'll just check if game state is equal to gameplay. And then we will only spawn 1 in if we're in the gameplay state, which is why this state system is so powerful. All right, we don't even need this in, we could just spawn in a new ball every time. And if it is not in game state, this won't happen. So let's test. It didn't work. My game manager says I'm in game over state. Why am I in game over state? Did I totalize as 3? Oh. Who saw that and got mad at me? If I have more than 0 lives, I want to be in... if I have 0 lives, I want the state to be game over. If else, I want to spawn in the new ball. I don't want to set the game over whenever my lives are. Anything. Okay. Yeah, that was confusing me earlier because I was like, I feel like I switched to game over too soon. Say off by 1. There we go. Whoops. Okay, well, I can't play this game very well. But I don't need to. Moving to the side. There we go. So that last ball still exists, but I'm in the victory state. Great. So should we destroy the last ball? But that's our game manager. We just need to create a bunch of bricks. We need to make them not square and put them in our scene. I'm going to control the positions of this. 1, 2, 3, 4, 5, 6, 6 maybe. make a script. The video's over. I'm doing an extra thing for fun where I spawn it automatically. So you're seeing me not explain all my steps out loud because whatever. Game object brick prefab and then maybe I'll just have the brick spawner be the start location, top left location. Do a little loop-de-doop. Yeah, we use our current position as the start position. And then we'll I times some gap amount, j times some gap amount. Prefab at position at say not rotated. I just got the Unity mathematics library in here. I don't want that. I want a capital Q. And then we'll set that to dot get component. Exact same logic as the ball here, but I'm just doing it on one line of code instead of just adding it in one line of code. So I don't need, I have one less variable. Set game manager, and then I have my own. Ooh, not you. What did I call you? Call you that. That function doesn't exist. Auto-generated it. Game manager equals game manager 1. We'll do rename that to that. Make that private. That 1. I despise the 1. Great. Same logic as the ball. We made a setter, set a variable to that value. Because something is spawning it in, it can handle that for us, so I don't need to drag and drop the reference 1,000 times. Great. So brick spawner, you take the brick, take that out of the scene. Game manager, 6, 3, separation. How is it? 3, 1, something like that. I went up, not down. I went up, not down. Negative j times separation dot y. Okay. And then I think that was 0.75. I think that needs to be like eyeballing things here. Okay. So I really want that to be gap. I want that gap to be That feels good. I want a little bit smaller gap on Y. What was it? We'll do 1.85. And then what, 2 more? If it's 0.75 scale, then 1 unit. Yeah. All right, I can live with that. My paddle, I can't live with this paddle. Now we can raise that ball spawn start. We can shrink that to 3. Okay, so that's the real end of the video. I just wanted to have a little bit of fun with the, is that centered? It's not centered. I should figure out, I should calculate automatically what the center is, or whatever. Sure. I mean, there's definitely like a correct answer to that, but our edges are also off, just so I have that debug like visual confirmation that I hit them. I lost. Okay. So that last 10 minutes there was totally extra, but in the next video, we're going to add polish and make it interesting and fun and not boring. And we're going to show you win and you lose on the screen. So, great.